TTP specializes in visual presentation of technical information, whether explaining an entire power plant layout. The steam turbine receives the steam from the heat recovery steam generators to produce power, which increases the overall efficiency of the facility. Or clearly illustrating chemistry fundamentals, RO basically uses the water pressure produced by a pump to push water molecules through a specialized plastic filter, while leaving hydrated ions behind. Or illustrating component maintenance procedures. Remove the 4 mounting screws. Pull the drivetrain out. Our detailed 3D animation courses allow trainees to quickly understand complex design, operation, and troubleshooting concepts. Our realistic computer-generated content, mixed with control screens and site photos, allows the viewer to not have to imagine but clearly see the internal workings of combustion turbines, boilers, and generators. Our content also allows users to clearly view assembly, disassembly, and troubleshooting of components such as actuators, large combined stop and control valves, and many other industrial components. Unlike typical engineering or architectural walkthroughs where 3D models are shown but not pulled apart and explained, TTP takes the time to model, then fly through or disassemble systems and system components to clearly explain function, design, operation, and troubleshooting. The main steam line connects to a single combined main steam stop control valve, or MSCV. The 2 valves operate independently of each other, but share a common casing. The stop valve portion of each MSCV is also used for quick and complete isolation of main steam to the steam turbine. The stop valve is slammed shut any time a trip condition occurs with the steam turbine. The control valve of the MSCV is used to control the amount of steam flowing to the steam turbine. Once the stop valve is open, the control valve will regulate steam flow. As increased generation is demanded, the control valve will open to admit more steam to the steam turbine in order to meet this additional load. Similarly, if load demand is reduced, the control valve will close to admit less steam to the steam turbine. TTP also includes graphics, such as control screens, where specific control and monitoring functions are performed. By mixing explanations of the control screen with 3D flow paths and design review, a critical connection is made between control screen representation and actual flow paths and component function. The PM valves each regulate gas flow to 4 independent headers, each of which will supply an associated PM nozzle or nozzles at each can. During startup, after the start sequence is complete with the purge cycle, the machine will ramp down to 475 RPM and back to firing speed of 505 RPM. At this point, PM1 and PM2 valves will open. This is called Mode 3. The igniters will light. Another beneficial feature of our content is our ability to show site overviews for both site familiarization and site safety overviews for visiting employees, contractors, and others. The Plant 3 Power Center is a state-of-the-art facility that uses natural gas-fired gas turbines to generate electricity. To increase overall plant efficiency, The exhaust heat from the gas turbines is used to create steam in the heat recovery steam generators, or HRSGs. Natural gas from the local pipeline enters the facility through its compressor station, used to raise the pressure if necessary. The gas is further conditioned at the turbine gas skid, which provides heating and filtering. Each turbine will produce approximately 170 megawatts. The exhaust from the gas turbines will pass through the heat recovery steam generators to capture the energy of the exhaust gas. This energy is used to boil water at 3 pressures for use in the steam turbine, producing up to 40% more power from the plant from the same amount of natural gas. These site overviews can be produced cost-effectively in English and other languages. They can be used for plant explanations on corporate websites, as well as used for site purposes such as new employee orientation and contractor safety orientation. As mentioned, 3D animation is also useful when explaining assembly and disassembly of complex components such as actuators or large steam valves. Incorporation of our animations into computer-based training allows trainees to go directly to a specific step or set of steps to review disassembly, assembly, or troubleshooting steps. TTP also creates training modules which provide interactive reviews of control screens from the site while leveraging plant startup procedures. Our control screen overview courses integrate well with our 3D content to provide a comprehensive overview of a plant's design, component and system function, plant operation, and component maintenance. TTP also can provide a large range of safety and fundamental subjects ranging from arc flash to valve basics. TTP can cost-effectively create translated content, such as the Spanish version shown for an LM6000 combustion turbine. TTP currently is developing content for combined cycle plants, simple cycle plants, coal-fired plants, boiler cycle chemistry for gas and coal-fired units, Makup water treatment, and wastewater treatment. To contact TTP or to view a wide range of examples, go to the TTP website at www.tektrapro.com.